All right, this is a homework for our first vectors. Use the vector in the picture to answer each question. Questions 1 through 4, find the vector components of each vector. So I'm going to do that in this picture, then I'll add it down below. Vector u is going to the right 2, and it's going up 1, 2, 3, 4. So vector u would be components x and then y, 2, 4. Vector v is going left 2, so that's negative, and it's going up 2, that's positive. So vector v has components of negative 2, positive 2. Vector w goes left or right 0, and it goes down 3. Vector s is going to the right 1, 2, 3, 4, 5, 6. Right's positive, and it's going down 1, 2, 3, 4. Done. Find each vector calculation algebraically or graphically, and that is referring to questions 5, 6, and 7. So let's say I do 5. I'll do 5 graphically, and I'll write down the answer. So if I take vector u and v and put those together, let's say that I do something like this, where this is vector u coupled with vector v. The resultant of that would be along this. Tell you what, that is not to scale. Let me start this over. Let's say we started with u here at the origin, and I went right 2 and up 4. Put me here. Then if I add v to that and I go up to the left 2, it's going to put me here. The resultant vector be this red vector here. Which looks like it just went up 1, 2, 3, 4, 5, 6, goes left to right 0. So the resultant of that is going to be 0, 6. I can easily check that algebraically. If I add u and v together, add the x values, you get 0. Add the y values, you get 6. It's that simple. I'll do the next one algebraically. So I have to double vector w, and I have to add to that 3 times vector s. And I'm just getting the components from my previous answers up above. So that's going to be 2 times 0, which is 0. 3 times 2 times negative 3 is negative 6. 3 times 6 is 18. 3 times negative 4 is negative 12. And if I add the x components together, I'm going to get 18. If I add the y components together, I'm going to get negative 18. Number 7, I'm going to take negative 10 times u. The components for u are 2, 4 up above. Then I'm going to add to that a negative 3 times the components for v. V was negative 2, 2. It's going to give me negative 20, negative 40, plus 6, negative 6. Add the x components together, you get negative 14. Add the y components together, you get negative 46. For these last three problems, draw each vector on the coordinate plane below with its tail at the origin. Label the vector in the picture. So 8 is negative vector v. So vector v up here, which is this fella, went left 2 and up 2. So I'm just going to draw this for reference. This was the original vector v. This negative means we change the direction. So instead of up and to the left, it's down and to the right. Magnitude hasn't changed, it's the same length. So this would be vector, this would be negative vector v. Number 9, 3 times vector w. I don't have space to do that, but we'll figure it out. Vector w is down 3 units, 3 times that. So that's down 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe something like this. Probably should have thought that out a little bit better before I made that problem. 10, negative 1/2 s. So s is down and to the right. If it's negative, it's up and to the left. So s went to the right 6 and down 4. If we cut that in half and go in the opposite direction, s is going to go left 3 and up 2. This is negative half of vector s. Everything's labeled correctly. All right, that finishes the homework.